Today, I want to show you all the stages I went through while assembling my autonomous indoor delivery robot. It is a pretty much standard 2-hub motor wheel differential drive system with 4 caster wheels. I made a simple spring-loaded mechanism where wheels are sliding on aluminum stands. This should make it simpler for the robot to pass small unevenness of the floor. Wheels are connected to a breakout board I've created and are controlled by a O-Drive 3.6 BLDC motor controller. The robot is powered from a 6S4P lithium battery. There are ultrasonic distance sensors on the front and on the back of the platform for safety, which are connected with an RS485 bus. Here is a power distribution board, quite a typical one used in drones. Beneath it is a drone can battery gauge board for monitoring battery usage and charging. Finally, you see the charger port, which I've built using charger connector spare part from Xiaomi vacuum cleaner. As the next step, I install aluminum panel, which will close the base part of the robot. 4 caster wheels are mounted on the bottom side of this panel. On the top side, I mounted a 2D LiDAR from Slamtech. I've routed a USB cable from O-Drive board just in case I need to change its configuration in the future. I've also brought out through the panel power and control cabling which will go to the top part of the robot. Those include USB and power for the LiDAR, 24 volts main power, 2 CAN buses for motor controller and for drone CAN devices, and finally RS485 bus from ultrasonic distance sensors. Then I install aluminum 100mm stands on which the top part of the robot will be mounted. Finally, I install the panel which will be used to mount the top part of the robot, and I bring out power and control cables through it. So now we have kind of universal indoor platform, which can be used to build different types of robots. This platform will enable robot movement and will also provide some of the navigation and safety sensors robot needs. I build an office delivery robot, so next, I will assemble it floor by floor, if you will, on top of this universal platform. Robot will deliver the orders in sliding bins. I decided to use controller from one of my previous projects to control bins actuators. Every floor is constructed from an aluminum panel and 3D printed walls. I split walls into smaller parts to fit them into 3D printer build volume. The design of the walls includes stiffening ribs with platforms on which the panels rest. The parts are fastened to each other with M4 screws. This way we get a modular enclosure which can be built step by step while printing parts in parallel. Control and power cables go vertically through the whole enclosure up to the top panel. The platform and the enclosure are ready. The top panel is mounted, so we can move our robot to the floor and start to install control electronics, which will be the brain of our robot. I've installed a 9-inch touchscreen which customers will use to interact with my robot in future. I've mounted DC-DC power converters for 5 and 12 volt supply, power distribution panels, CAN and RS485 bus gateway, the main brain of the robot, NVIDIA Jetson Orin Nano board, and also a kinetic router, which connects my robot to the internet through cellular network. Luckily, the touchscreen works. Busy showing a simple animation I wrote with PyQt. I've mounted the walls to the top panel. Here you can see speakers connected to the Jetson board. Robot will use those to play different sounds to notify people around about its actions and movements. My robot is ready for testing. One of the first tests after robot bringup. I wanted to see if charging contacts are going to work. So I wrote a simple script, which makes robot slowly going backwards until battery starts charging, and it worked. Let's wrap up the interim results of my project. Robot-based platform proved to be a working one. Robot moves normally on the floor and is able to pass over small unevenness of the floor. There is another video about those tests on my channel. All robot components are working. I plan to show you sliding bins and how their actuators will work in next video. If you like this video, please subscribe to my channel. Hope to see you again.